everyone from Institute of Aeronautical Engineering. Myself, Dr.M Purushotham Reddy, Associate Professor and Head of the Department of Computer Science and Engineering. Today we are going to discuss about minimum spanning trees and also Prim's algorithm. How to find the minimum spanning tree using Prim's algorithm. Today, in today's class, we discuss that one. Now, here you see that first, what is meant by first year. What are the core subjects of this course? This design and analysis of algorithms. The students will try to learn mathematical approach for analysis of algorithms, methods and techniques for analyzing the correctness and resource requirement of algorithms, different paradigms of algorithms, algorithm designs including recursive algorithms, divide and conquer algorithms, dynamic programming, greedy algorithms, backtracking, branch and bound, and graph algorithms, strategies for solving problems not solvable in polynomial time. These are the core objectives of this course. Next, at the end of this topic, which the student will learn means, here after completion of the course, the students will able to apply greedy algorithm for finding solutions for minimization and maximization problems. So this is the course of the outcome. After completion of this course, the student will easily find the minimization and maximization problem solution. Next, so minimum spanning tree. First, spanning tree. So what is meant by spanning tree? A tree which contains all the vertices of the graph, and they are either connected or acyclic graph. That one is called as spanning tree. Minimum spanning tree with the minimum sum of weights. Spanning tree with minimum sum of weights. That one is called as minimum spanning tree. Spanning forest. A graph is not connected. Then there is a spanning tree. Tree for each connected components of the graph. Then that one is called as forest. So spanning tree means the tree which are not cyclic. The tree which are not cyclic, and as it consists of all the edges of the given graph. Vertices of the given graph. Then that graph, then the tree is called as a spanning tree. And second reason, the graph which consists of all the vertices of the tree, vertices of graph with minimum cost, which is acyclic. Then that one is called as a spanning tree. Now, applications of minimum spanning tree. Where we are using this minimum spanning tree. Here we discuss that one. Find the least expensive way to connect a set of cities, terminals, computers, etc. So in these situations, using this minimum spanning tree. So suppose we connect a set of cities, we connect terminals, we connect computers. Now here, this is the first example. This is second example. So in all these situations, using this minimum spanning tree. So connecting two cities or more than two cities using different roadways. So among that one, we choose minimum cost way or minimum distance path using this minimum spanning tree algorithms. Connecting two or more systems in the lab using LAN. How to connect that one with minimum cost using this LAN. So in that way also using this minimum spanning trees. Next here. So here minimum spanning tree where we using here. Once again here we see here some problem is given. The problem is a town has a set of houses and set of roads. So a road connects two and only two houses. Road connects two and only two houses. A road connecting houses U and V has a repair cost W of U comma V. Now repair here, the goal is repair enough roads such that everyone stays connected. That is, can reach every house from all other houses. total repair cost is minimum. Here, minimum is the total repair cost. That is the motto here. Now here we see that here a road connects here two houses. That is one condition. And also here a road connecting that houses U and V has a repair cost. How much cost? W of U comma V. So here minimize the cost and also connecting all the houses. Here we see that here this is the houses. These are the roads. So these roads repairing cost also here is given. This 4, 8, 11, 8, 7, 2, 6, 4, 1, 3, 7, 9, 14, 10. These are the repairing costs. So how to minimize this cost? Here we see that one in next diagram here. Here we see that a connected undirected graph. Here vertices, these are the vertices. These are houses. These edges, these are called as roads. A weight W of U comma V and each edge U comma V belongs to V. Edge. This is the edge. Now here first find T subset of E such that T subset of E means edge set. That T is one of the edge. That edge belongs to the edge set. T connects all vertices. T connects all vertices. W of T equal to summation U comma V belongs to T. W of U comma V is minimized. That is the condition here. Now here how to minimize? Here we see that here this house connects with this house and also this house and this house. Among this house, this is the minimum cost value. Connect this one. Next here, this house connects with this house and also this house. This is the minimum cost value. We choose this one. This road we want to repair that one. Next, these two houses connects with this value. This is the minimum value. So we connect these two values. Next, this house is connects with this one. Among this minimum value is 6. So we connect this one. Next here, this 2 is minimum value. Connect this 2. And also here, this house, it has minimum cost value 4, 14, 10. But here, suppose you choose this road 4, it forms a loop. So we won't choose this one. In the remaining 2 value, this 10 is the minimum cost value. We choose this one. This house connects with this only this road. This is 9. So we choose this one. So now this is the minimum cost spanning tree which is used to repair these roads. So this is the finding the minimum spanning tree. Spanning tree means a tree which has no loops, which is acyclic, but it consists of all the vertices of the graph. That tree is called as spanning tree. Minimum spanning tree means we draw the spanning tree with minimum cost values. That one is called as minimum spanning tree. Now, properties of minimum spanning tree. Minimum spanning tree is not unique. So it is not unique. Different persons they draw in different ways. Now this is one spanning tree. This is one spanning tree. This is another spanning tree for this one. So one person draw like this, or one way drawing spanning tree is this one. Another way drawing of this same graph drawing spanning tree is this way. So we draw in different ways. We draw the spanning tree. Minimum spanning tree has no cycles. So we can take out an edge of a cycle and still have the vertices connected while reducing the cost. So compulsory we won't take the cycles. That means whenever drawing the minimum spanning tree, compulsory we avoid the cycles. Spanning tree means it is a cyclic graph. So we avoid the cycles. So the number of edges in minimum spanning tree is modulus of E minus 1. So modulus of V means it is number of vertices minus 1. So that is the formula for finding minimum number of edges in minimum spanning tree. Next here. Connects. So what is the requirement of minimum cost or minimum spanning tree? That requirement is connects all nodes at minimum cost. So that is the requirement of this minimum spanning tree. Now this is the given graph. It consists of the cost values 2, 3. So this is the edge of the edge cost. This is another edge cost. Now here you see that this is edge cost value is 1. This edge cost value is 2. Here 2, 3. This edge cost value is 3. This is edge cost value is 1. Now here minimum cost means any spanning tree consists of all the vertices, but it won't form any cycles or loops. That tree is called as spanning tree. We draw that spanning tree with the minimum edge cost values. Then that one is minimum spanning tree. Now here you see that here this is a spanning tree. Suppose you draw like this here, this minimum spanning tree, this cost value is 1 plus 2 is 3. Suppose you draw the spanning tree of the graph is like this cost value is 2 plus 3, 5. Suppose you draw for that same graph, you draw the spanning tree like this. So here cost value is 1 plus 3 is 4. So among this minimum cost value is this one. So this graph is called as minimum cost spanning tree or minimum spanning tree. Now, yeah, required all nodes at minimum cost. Cost is sum of edge weights. Can start at any node. You start at any node. Unique solution can here we won't find the unique solution to draw the minimum spanning tree. A minimum spanning tree it consists of a unique solution, whereas in spanning tree there is no possibility to draw a unique way of minimum spanning tree. So it can come from different sets of edges. Now here you see that for this graph, here we take this is one way of drawing spanning tree. This cost is 4 plus 4 8. This is minimum cost. Suppose we draw like this. Here also 4 plus 4 8. Suppose we draw like this. Here also minimum cost value is 8. So here if there is no unique way, we draw in any ways, but the final minimum cost is same. Next here. So here to finding this minimum cost spanning tree, mainly here we have two algorithms. One is Prim's algorithm, another one is Purushotham algorithm. So first we are going to discuss about Prim's algorithm. Now here you see that first algorithm. So in this algorithm, Prims of E, cost, N, T. E is number of edges. Cost is the cost of that edge. N is number of vertices. T is that tree. Now here tree, that means the edges in the array, that is 1 row n minus 1 or 1 to 2. These are the trees in the trees, the edges in the tree. Now here you see that let k comma l be an edge of minimum cost in E. So k comma l, it is a edge in the. So first we choose that minimum cost value. Minimum cost k comma l equal to minimum cost. So we assign that cost of k comma l to minimum cost value. Next t of 1 comma 1 equal to k. The starting first vertex value, first vertex is k. Second vertex is t of 1 comma 2 is n. So connecting these two edges, that cost is minimum cost of k comma n. So in Prim's algorithm, we start from starting vertex. So for I equal to 1 to n2. So now the nearer edges are nearer vertices. So to connect this first vertex with remaining vertices, among that edge cost value, we choose the minimum cost value. That's why here we write that condition is if cost of I comma l less than cost of I comma k, then near of I equal to n. Yes, near of I equal to k. So if that condition is satisfied, near of I value is l. That means that is the minimum cost path Otherwise, we choose the next path. Next path is the minimum cost path. Next one here. Continuation of that algorithm. For I equal 2 to n minus 1 do. So already we choose one edge. So or one vertex. So we're repeating this one for the remaining n minus 1 vertex. So here we write I equal 2 to n minus 1 do. So let j be an index such that near of j not equal to 0 and cost of j comma near of j is minimum, and cost of j comma nearer of j is minimum. So if that value is minimum, t of I comma 1 equal to j, t of I comma 2 equal to near of j. Now min cost equal to min cost plus cost of j comma near of j. So we check here, we check the condition. If that present here one vertex is connected with suppose another 3 vertices, suppose that cost value is 2, 4, 6. Among this value, which one is minimum? We choose that minimum value as minimum cost value. So first here compare that first here this is the, suppose we choose this is the minimum cost value, compare this one with the remaining 2 values. Suppose this value is lesser value, this is the minimum cost value. Otherwise, suppose this value is more than the remaining any one of that value. Suppose this value is some 4, this value is 2. 4 is greater than 2 means now 2 is the minimum cost value. Choose minimum cost edge. So like this we continue this one for the remaining all vertices. So near of j equal to 0. For k equal to 1 to n do. So now here for k equal to 1 to 2, so now update all that vertices in the minimum spanning tree. So if nearer of k not equal to 0 and cost of k comma near of k greater than cost of j, then nearer of k equal to j. We choose that nearer of j. That means that minimum cost path value. So finally return. So completing the repeating for all these vertices and edges. Finally, we get the minimum cost value. So we return that minimum cost value. So this is the Prim's algorithm. In Prim's algorithm, once again listen. In Prim's algorithm, first we start from the starting vertex. So here from starting vertex to remaining vertex, we have so many paths. So among these paths, which has less cost or minimum cost, we choose that path. So now move to second vertex. So from that to second vertex also again we follow the same rule and also we find the minimum cost path. So up to a destination vertex we follow these things, and also finally we get the minimum cost path from source to destination. That minimum cost path we return. So this is the procedure of Prim's algorithm. Now here once again we see the procedure. Start with any vertex. All its edges are candidates. Stop looking when all vertices are picked. Otherwise repeat. Pick minimum edge and connect the adjacent vertex. Add all edges from that new vertex to our candidates. So pick any vertex and add it to vertex list. Loop, exit if. Select shortest unmarked edge coming from vertex list. If shortest edge does not create a cycle, then add that edge to your edges. Add the adjoining vertex to the vertices list. And if mark that edge as having been considered and end the loop. So this is the general procedure of Prim's algorithm. Now here you see this is the problem to find minimum spanning tree using Prim's algorithm. Suppose we start here. This is the starting vertex. So it connects with 3 other vertex. So this edge cost value is 5. This edge cost value is 9. This edge cost value is 3. So among this, minimum cost edge is 3. So we choose that one. Now here we travel here. Now it consists with 2 edges, 2 vertices. This vertex with the minimum cost value 15. They connects with this vertex with cost value 24. Among this, we choose minimum edge. Otherwise, again, so here 15, 24, and also here this vertex also it connects with the minimum cost value 5. So now here we observe that this 5 is lesser than this 15 and 24. We choose this 5. Next. Now here we're reaching here. Now here it connects with 18 and 14 and also 4. Among this 4 is the minimum, so we choose this one. Next here we come back to here. And also consists of 2, 7. So 2 is the minimum value, we choose this one. Next here. Next year we already reached here. Here 6, 21. So minimum value is 6, we choose that 6. And next here this vertex it consists of 8 and 19. Minimum value is 8, we choose that one. But here 8 and also here we see. So any vertex it has a less cost value, we choose that one. Here it has 7, we choose that one. Now here we come here. It consists of with 8, 10, 20, 18. Here also see any vertex it consists of any minimum cost. So among this 8 is the minimum cost value, we choose that one. But whenever you choose this one, it forms a loop. So it forms a loop means you won't choose this this path. So we will come back to here, and also next minimum cost value is 10, 20, here 12. Here this connects with 18. It forms a loop. It connects with 14. It connects with 9, and also 15. Here 9 is their minimum cost value. So we choose that one 9. Next here again we come here. We already reached here. Here we choose this 14. It forms a loop. We choose this 15. It forms a loop. Next minimum cost value is 13. But here already this we won't choose 8. Next minimum cost value is here. 10 is there. So we choose the 10. Next here we're reaching here. Here this minimum cost value is 9. Suppose you connect it forms a loop. It forms a loop. It forms a loop. It minimum cost value is 13. So this is 9. 9 is a lesser value. So we choose that minimum cost edge. Next here. It consists of 17, 24, 13. Here 14. It forms a loop. Suppose we choose this 15. It forms a loop. The 13 it forms a loop. So we choose only 17. Here 11 is there. So we choose 11. 11 is the minimum cost value. Now we choose 17, it forms a loop. So now we choose any path, it forms a loop. And also here we observe that all the vertices in this graph we covered. So now this is the minimum cost value. So the minimum cost value is how much? 66. We add all these edge cost values. This is the minimum cost value. This is the minimum spanning tree. Minimum cost spanning tree. We draw this one using Prim's algorithm. So once again, here we see that. Once again, listen. Once again, I'm repeating this one. So we start from anywhere. Suppose we start from this vertex. Minimum cost is 3. So we take that edge. 3, 5, 9. 3 minimum cost. Among this minimum cost is 3. We choose that one. After choosing this one, now here we see that. Now this vertex it consists of 15, 24. And also this vertex also joined with this edge. So this vertex it consists of 5 and 9. Among this minimum cost value is 5. We choose that 5. So now reached here. Now minimum 4, 18, 14, here 9, 15. We choose all the minimum cost values which are in this path. So minimum cost value is 4. We choose this one. Now next here. Here 2, 7, here 18, 14, 9, 15, 24. Among this minimum is 2. So we choose this one. Now 6, 21, 7, 18, 14, 9, 15, 24. Among this minimum value is 6. We choose that 6. Next here. 8, 19, 21, 7, 18. Minimum cost value is 14. Here cost value is cost of the edges which are connected, the vertices which are in this path. 9, 15, 24. Among this minimum value is 7. We choose this 7. Next here. Already we reached here. Here 8, 21, 18, 14, 12, 10, 20, 9, 13, 9, 15, 24. Now here, suppose you choose this 8, it forms a loop, so we won't choose. Now minimum value is here, it connects here, it is 10, it is 18, but it forms also loop. Here it is 14, it is 9. So among this 9 is the minimum value, we choose that 9. Now reach it here. Next, here the nearer points already we won't choose this one. This is 10, this is 19, this is 10, this is 19, 20, it forms a loop, 18, it forms a loop, and also it is 13. Among this 10 is the minimum value, we choose 10. Now here 9, 11, 20, 12, it forms a loop, it also forms a loop, 15, it forms a loop, is 15 and also 24. So among this minimum value is 9, choose 9. So now here it forms a loop. So here it forms a loop, it also forms a loop. So this edge also forms a loop, this edge also forms a loop. Remaining only 2 are there, 11 and 17. Among this minimum value is 11, we choose that one. Now here observe that we choose any edge now. From the remaining edges we choose any edge, it forms a loop. So we won't choose that edges. And also here we observe that. So in this path, all the vertices in the given graph are covered. And also in this path, no edge forms a loop. So now this is the minimum spanning tree which is drawn by using Prim's algorithm. So what is the minimum cost value means? Here 3 plus 9, 12, 12 plus 5, 17, 17 plus 4, 21, 21 plus 2, 23 plus 7, 30, 30 plus 6, 36, plus 10, 46, plus 9, 55, plus 11, 66. 66 is the minimum cost of this spanning tree. So that is shown here. So this is the minimum spanning tree with the minimum cost values, and that minimum cost value is 66. Thanks everyone.
Like, share and subscribe. Hit the bell icon for more updates.